All right, let's do some applications. This first video will have two applications that are one way. And then the next video is going to focus on like revenue and profit applications. So let's go back to this first application. Same situation as before. October, don't step on my tablet, please. And where we had a blue backyard, right? And then we were making a garden inside of that backyard. We said this is going to be L, this is going to be L, this is going to be some W. We had a total of 80 feet for this garden. All right, and we want these three black sides to add up to 80. And we're going to find the dimensions of the fence that maximize the area of the garden. We want to maximize the area. Okay, so again, we could set this up as a linear program, but let's find a different way of doing it. And we're going to be using this different way in some problems in this chapter. Okay, starting with this section. What is the area? Well, the area of a rectangle is length times width. That's not too bad. But that's not a quadratic. Not a quadratic yet. And we know, so if we wanted to, we could write the words subject to. We could write a constraint here. Don't worry, don't worry. Not going to be that bad. We know that the fencing has to be no more than 80 feet. Okay. So this whole fencing can't be more than 80 feet. So you're going to say, okay, L plus W, or 2L plus W, has to be less than or equal to 80 feet. But I'm going to write an equal sign because I want to make the biggest the biggest garden I can. Let's just use all the feet. All 80 of them feet. Probably stinks. Wash your feet. Important. Anyway, and if we do that, we can actually maximize this function. Because if this is the case, we can solve for W. Solve for W and make our area function a quadratic. Watch this. So again, this is our linear program if you wanted. This is our problem. To solve it, let's solve our constraint for W. What's going to happen? Subtract 2L from both sides. W is going to be 80 minus 2L. And we want to maximize our area, which is length times width. So we want to maximize this length times width, and we know that the width has to be 80 minus 2L. So if that's the case, W is the same thing as 80 minus 2L. W equals 80 minus 2L. They're the same thing. So instead of writing a W, I'm going to substitute. Just like we're solving a system of equations. We got rid of one of our variables. Now we have a function. Our area function is a function of one variable. And if we simplify this function, distribute that L, 80L minus 2L squared, by George, there's a quadratic. We want to maximize a quadratic function. Does this quadratic function open up or down? Let's put it in standard form. Standard form, AL squared plus BL plus C. There's no C. The A value is negative, right? A is negative 2. B is 80. C is 0. This area function is a downward facing quadratic. Where's the biggest value? Where's the biggest function value? Function value is the output. It's the y coordinate on the graph. So if you have a graph that's opening up downwards, the biggest the graph ever gets is at that vertex. We know how to find a vertex. It's all coming together right here. So let's find the vertex. Right, the max is going to be at vertex. to find the vertex. So in general, vertex is going to be at HK. And H is going to be negative B over 2A. Opposite of B is negative 80 over 2 times A is 2 times negative 2. That's going to be negative 80 over negative 4. The negatives cancel. We're going to get H is at 20. And this is where, like, again, we need to use H. What is H? H is the input, right? H is the input here. We could also write L, because L is our input of this function, right? Our input is L, and our output is A. Output is A. So HK, right, is really L comma, right? That's the L value here, and that's the area value here. This tells us this maximum happens. The maximum area happens when our input is a length of 20. When this L up here is 20 feet. Well, if this is 20 feet, and this is 20 feet, what dimensions maximize the fence? Well, we have 80 feet total. We've used up 40. W has to be 20 feet. Just like when we were solving system of equations, if we eliminate a variable, we have to find the other variable. So again, we could also find out what A is. A is a function value when we plug in 20. So A is going to be 80 times L, which is 160. 1600 rather. Minus 2 times L squared. Our maximum area is 800. These are in feet. And we need to find the W. The W, we're going to use this. W is 80 minus L. We know L is 20. So W is 80 minus 2 times 20. Our width is 40 feet. Okay. So when you have a physical problem, we won't deal with a lot of physical problems. We'll deal with more like business applications. When you have a physical problem, essentially what we're doing is set up what we want and then eliminate a variable. And then find max or min at the vertex. And our last step is going to be interpret. I can't spell. Well, let's do that and be done with this problem and move on to the next one. It would be more applicable to us. All right, so our fence, our garden should be 20 feet by 40 feet. Maximize its area. And I don't think it asked what the maximum area was. We don't have to say it, but I will. Maximize its area, which is going to be 800 square feet. Oops. I forgot the squared here. It's area, so it's square feet. Volume would be cubic feet. And this is our answer. All right, let's do something a little bit more applicable to us. A local newspaper has 84,000 subscribers, and there's a quarterly charge of $30. They did some market research, and that said that if you raise the price a little bit to $32 every quarter, you're going to lose 5,000 subscribers. Assuming the subscriptions are linearly related to the price, that's important. Find the price the newspaper should charge to maximize their revenue. Ooh. Okay. What variables do we have? What are we trying to maximize? How do we solve this problem? We're trying to maximize the revenue. What's the revenue? I don't know. What are our variables? What price should they charge? Oh, okay. So let P be the price in dollars. Really dollars for a quarter subscription. And then, so what is the revenue then? It's going to relate to the price, right? Whenever we're selling something, the revenue is just what are we charging and how many are we selling? We need a new variable, right? Q be subscriptions, or you could let S be subscribers. That's going to be really important as well. And I'm going to put in thousands. I don't want so many zeros. Look at how many subscribers this newspaper has. 84,000, 5,000. I don't want to write all that. So then what's revenue? Then revenue in thousands of dollars is just going to be P times Q. What price? How many subscribers? So if one thing is in thousands, they have to both be in thousands. Okay. And what do we know about the relationship between P and Q? Right? We're really following the same steps as before. We're maximizing some function with two variables. And then we say, what's the relationship between those two variables? What is the relationship between P and Q? Subscriptions Q are linearly related to the price P. We're going to have a line here. Q equals B plus M times P. We have a line. Doesn't matter which place Q goes and which place P goes. Okay, your choice. P could be B plus MQ. You could switch your P's and Q's. It's fine here. Because if one thing is linear related to the other, then you can solve for X or Y in that case. We just have to find out this information. What's our B value? What's our M value? Once we find the line, then we'll be ready to move on with the problem. Also, if this is a little overwhelming to you, you're not sure where these steps are coming from, these are kind of like introductory examples to show like the thought process. We do have a step-by-step method in the next video that we're going to talk over that'll help out a little bit with these. All right, so let's find this equation down here, Q, B, M, P. We need all this stuff. Anytime we're trying to find the equation of a line, it's usually best to start with a slope. Slope is change in output over change in input. Usually we deal with y's, but the way that we've written our line, our output is not y here, our output is Q. Change in output divided by change in input. It's rise over run. Y2 minus Y1 over X2 minus X1. But we have different letters here. So we need 2 points. Do we have 2 points? I don't know. We should have points that have an X coordinate P and a Y coordinate Q. Do we have any of those? Do we have a relationship between price and subscriptions? Oh, yeah, we do, right? Right now we're charging $30 for 84,000 subscribers. A price of $30 is 84,000 subscribers. Remember, Q is in thousands. Well, we need another point, right? This can be our first price and our first quantity, but we need another point. We'll use the market research. If they raise the price to 32, use that as our second price, we think the subscribers would fall by 5,000. So they'd be 79,000 now. We would lose 5,000. Hey, we've got 2 points. We can find an equation of a line if we have 2 points. No problem. So that'll be second price and the second quantity. Now we can use the formula. Q2 minus Q1 over P2 minus P1. That's going to be -5 on top, 2 on the bottom. Our slope's -5/2. The Q is B minus 5/2 times P. Now we need B. We can use either one of these points. All right, either one of these points will work. Let's use 30 and 84. Quantity is 84 when the input is 30. Solve for B. We'll get 84. It's B minus half of 30 is 15. 5 times that's 75. Add 75 to both sides. When we do that, we get 159 as our B value, I think. So we finally have our equation of our line. So if we wanted to, we'd use the same language as earlier. Subject to the fact that Q is B, which is 159, plus M is minus 5/2 times P. This is our problem. Maximize the revenue, and we know this is the relationship between quantity and price. Before we go further, let's make sure that this line is right. Q is 159 minus 5/2 P. Oops. Something really weird happened. Q equals 159 minus 5/2 P. Does this make sense? Does a price of 30? What does the price of 30 have? 84,000 subscribers. That's what we wanted. If the price is 32, what does that get us? Price of 32, 5,000 fewer. Now we only have 79,000 subscribers. You can see the relationship between price and quantity sold. As the price increases, as we go to the right, the subscribers are going to decrease. Cool. So it looks like that's the right demand equation. All right, this is talking about demand right here. So let's substitute. Q, right, is the same thing as 159 minus 5/2 P. We can get our revenue function to be a quadratic again. Revenue is price, P, times quantity, Q. And we said Q was 159 minus 5/2 P. There we go. We got another quadratic. Let's simplify by distributing. So R is 159P minus 5/2 P squared. You could rewrite this in standard form if you want. Or you could just say the A value here is -5/2. And the B value is 159. The C value is 0. It might help to put this in standard form to see really where that A, B, and C come from. Either way, the vertex is when our input, and our input here is P, when our input is -B over 2A. What is that? -159 over 2 times -5/2. Watch your algebra or arithmetic. I don't know. You can use a calculator. Top, it stays the same. -5/2 of 2 is -5. Negative divided by a negative is going to be positive. This is going to be like 30.8. Let's use a calculator. 159 over 5. 31.8. That's why we used a calculator. So we found the optimal price. Right? We said the revenue is a downward facing parabola. Where's the maximum revenue? At the vertex. Where's the vertex? When the input, our input variable is P here, when the input is $31.80. All right. So even though raising the price to $31.80 is going to lower the number of subscribers, we're also making more for every subscriber. So that's why we are going to actually want to increase the price. What price should they charge to maximize the revenue? They should charge $31.80 for a quarter of subscriptions, for a quarter subscription. There we go. We didn't substitute at the end because it didn't ask how many subscribers we were going to have. We could have found it. It didn't ask what the maximum revenue should be. We could have found it. But all they asked is what price should we charge? And that's our answer. We'll formalize this more in the next video. So if that was a little overwhelming or if you felt a little lost about why I was taking what steps I was taking, next video has more steps. Good luck. Bye-bye.